All right, you guys, we're now going to be talking about sector area. So you're probably like, Miss Long, I thought we already talked about sector area. That was the last section. Well, guess what? We're going to talk about how to find the sector area when we're given an angle in radians. So let's go back to that lovely Prezi to figure out how we find the sector area when we're given an angle in radians. Okay, so like before, basically, the sector area is a portion of the entire area of the circle. So we're going to start with our area formula, which is pi r squared, and then we're going to multiply it by the fraction of the circle that we're dealing with, which, if we're thinking about radians, if you think back to this slide, all right, well, if you think back to this slide, there are, sorry guys. In every 360 degrees, which is one rotation, there are 2 pi radians. So we're talking about one rotation. There are a little bit over 6.3 or so radiuses that fit the circle, or radii, I guess I should say. So there's about 2 pi, there are 2 pi radians in one full rotation. So that is going to be our full rotation of one circle. So this time it's going to be out of 2 pi. Now, when you're dealing with radians, the variable that we use when we deal with radians, when we're talking about an angle in radians, is this bad boy, which is called theta. Okay, so theta is the measure of the central angle we're given in radians that the sector involves. Okay, which in the Prezi I showed you that the pi's would cancel out, which reduces this equation down to, there's secretly a 1 up here, so 1 over 2, 1/2, times the radius squared times theta. Okay, so that's going to be our sector area formula that we use. So we're going to be finding the sector area using this nifty formula. So 1/2 r squared theta. All right, let's get going, you guys. All right, so I'm going to write down the formula real quickly before we forget. Okay, so, or at least I might forget, so let's go. All right, so area equals 1/2 the radius squared times theta. 1/2 r squared theta, which theta, don't forget, is when our angle is given to us in radians. Okay, so this says to find the area of a sector whose central angle is pi over 3 radians. Okay, this right here is going to be theta. This is theta. And whose diameter is 4, which eventually, this is not the radius yet, but eventually this will lead us to the radius. All right, let's get it going. Let's fill in our values. Okay, so I have area equals 1/2. Now, I currently don't know the radius, but how does the radius relate to the diameter? Well, the radius is half of the diameter. So I know my radius is half of 4 centimeters, which is 2 centimeters. So I'm going to replace that bad boy with a 2 centimeters. So it's going to be 2 squared times theta, which is pi over 3. Oh no. Sorry guys, my substitute color is green and I'm using pink. What's wrong with you, Miss Long? Alright, and then I just got to finish multiplying this. So this will be area equals 1/2 times 2 squared. 2 times 2 is 4. So that's like 4 over 1 times pi over 3. So I'm just going to multiply straight across. And that'll be donezo. Okay, so I'm going to bring this up here. So area equals 1 times 4, which is 4. And 4 times pi is 4 pi. Over 2 times 1 is 2. Times 3 is 6. And I can reduce that down, so I will. What is something that goes into 4 and 6? Holy hot dog, it is 2. So I'm going to divide both of these by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So area will equal 2 pi over 3. And guess what, you guys? We are donezo with that. So it's 2 pi over 3 centimeters. And don't forget an area, since we have 2 dimensions we're dealing with, the radius and the radius squared is really our dimensions. So radius times radius means we're in the second dimension. So it's going to be centimeters squared. And guess what? That problem is donezo. Bam.